Good morning, student. So today this is our sixth conceptual lecture on electrostatic, and today's the topic of discussion is what? Electric dipole. Now we will see what is electric dipole. Again we will see what is the couple that will act, or a torque that is acting on an electric dipole whenever it is kept in uniform electric field, or we can find out an expression for, or derive an expression for electric field intensity due to electric dipole at a point which is either along the axis of electric dipole, or that point may be a point on the equator of an electric dipole. So purposely here I had already shown a diagram where plus q and minus q are what? These are the two charges which are equal in magnitude but opposite in polarity, and they are separated by some finite distance to L. So I can define what is electric dipole. So the first definition, that is electric dipole, what you can say about electric dipole? A pair of, it is a pair of equal and opposite, a pair of equal and opposite electric charges separated by a finite distance. A pair of equal and opposite charges separated by a finite distance is called an electric dipole. A pair of equal and opposite electric charges separated by a finite distance is called electric dipole. Then the second term that you want to define, it is a dipole axis. It is what? Dipole axis. It is a line joining the two charges in electric dipole. Line joining the two charges in electric dipole is called a dipole axis. What is dipole axis? Line joining the two charges. Line joining two equal and opposite charges in an electric dipole is called dipole axis. The third one, what is axial line? What is what? Axial line. A line passing through dipole axis. A line passing through dipole axis is called axial line. A line passing through dipole axis is called what? An axial line. Now look at the figure. In this figure, O represents the center of the dipole, and here PQ is a line which is passing through center of the dipole O, and which is perpendicular to the axial line. XY represent axial line. XY is what? Axial line. AB is what? Dipole axis. So PQ is a line which is passing through, a line which passes through what? Center of the dipole, and which is perpendicular to the axial line is called, it is called as what? Equatorial line. So what do you mean by equatorial line? Equatorial line, it is a line, equatorial line is a line that passes through center of the dipole and which is perpendicular to the axial line is called what? Is called an equatorial line. Now remember, as far as the strength of electric dipole is concerned, strength of electric dipole is concerned, it is measured in terms of a quantity that is known as dipole moment. Electric dipole moment, or the strength of electric dipole, it is measured in terms of electric dipole moment. Remember, it is a vector. Electric dipole moment, it is a vector. So to define the electric dipole moment, here we are having the two charges plus q and minus q, they are equal and opposite. They are separated by a finite distance 2L. Remember, when I say 2L bar, it means it is a distance vector. 2L bar is a vector, it is a distance from negative charge towards the positive charge. 2L bar is a vector pointing from minus q charge to plus q charge. Pointing from what? Minus q charge to plus q charge. Remember, electric dipole moment, as far as the magnitude of electric dipole moment is concerned, magnitude of electric dipole moment, it is a product of magnitude of one of the charge and the distance of separation between them, and the distance of separation between the two charge. So the product of magnitude of charge and the distance of separation between the two charges will give you the magnitude of electric dipole moment. But because a 2L bar, it is a vector pointing from minus q charge to plus q charge, directed from negative charge towards the positive charge. So electric dipole moment, it is a product of magnitude of charge, and the distance 2L bar, which is the distance from minus q charge to plus q charge, will give you an electric dipole moment. Now from this here, see here, q is a scalar and 2L bar is a vector. So naturally the direction of vector p is same as that of direction of what? 2L bar. So remember very well that electric dipole moment, it is a vector. See here, I had drawn vector p. Electric dipole moment is a vector pointing from vector p. It has a direction pointing from what? From minus q to plus q charge. Electric dipole moment, it is a vector always pointing from negative charge towards what? The positive charge, from minus q charge to plus q charge. So as far as electric dipole moment P is concerned, if someone asks you what is SI unit of electric dipole moment, see here, electric dipole moment, it is Q into 2L. What is SI unit of charge? Charge is measured in coulomb. What is SI unit of distance between the two charges? It is meter. So coulomb meter, remember while writing the SI unit, either you have a hyphen sign, put a hyphen sign, or you may put what? Some gap between coulomb and that of meter, or otherwise it may seem to be centimeter. So be careful. The SI unit of electric dipole moment, it is coulomb meter. It is what? Coulomb meter. There is one more SI unit. There is another unit that is known as dBi, and it is denoted by what? A letter capital D. 1 dBi is equal to 3.33 into 10 to the power minus 30 coulomb meter. 3.33 into 10 to the power minus 30 coulomb meter. So this is all about the electric dipole moment. All about what? Electric dipole moment. Now let us have some short discussion on the natural dipole which are existing in our universe. All of you are familiar with a water molecule, H2O. That water molecule is non-linear. Water molecule is what? Non-linear, because the two hydrogen atom and one oxygen atom in a water molecule, they do not lie along the same straight line path. Means they are non-linear. Means they are what? Non-linear. Also here, see here, I had drawn a water molecule. This is oxygen, hydrogen, hydrogen. And here this line will represent the hydrogen-oxygen bonding in a water molecule. So the hydrogen-oxygen bond, two hydrogen-oxygen bond in a water molecule, they are found to be separated, or they are inclined at an angle of 105 degrees Celsius. And due to which, again you remember that as far as water molecule is concerned, its most of the positive charge were concentrated on the hydrogen atom, whereas most of the negative charges were effectively concentrated on what? The oxygen atom. And also it is clear, because here hydrogen oxygen bonding, they are separated by 105 degrees Celsius. So what we can say, that the center of positively charged hydrogen atom and negatively charged oxygen atom, they seems to be naturally separated. They are inherently separated. As positively charged hydrogen atom and negatively charged oxygen atom, their centers are naturally separated. Their centers are what? Naturally separated, means there is an inherent separation. So any such molecule in which the positive centers of positive charge and negative charge, they are naturally separated, such molecules they are called as a polar molecule. So water molecule is what? Polar molecule. Why water molecule is polar molecule? Because the centers of their positively charged hydrogen atom and center of what? Negatively charged oxygen atom, they are naturally separated. So that's why water molecule is what? Water molecule is a polar molecule. Again, you can have so many examples: ammonia, or you may have sulfur dioxide or sodium chloride. They are all what? Polar molecule. Whereas there is another type of molecule that will exist, that is known as a non-polar molecule. Remember, only for polar molecule we will have permanent electric dipole moment, whereas for non-polar molecule we do not have a permanent electric dipole moment. So what are non-polar molecule? Non-polar molecule are the molecules in which the centers of their positive charge and negative charge, they are what? They are one and the same, or they are effectively centered at the same point. Whenever the centers of positive charge and negative charge, they are centered at the same point. The molecules in which the center of positive charge and that of negative charge is one and the same, or they are effectively centered at the same point, then they are called what? Non-polar molecule. Examples of non-polar molecule is what? Hydrogen molecule or chlorine molecule, carbon dioxide, or that of CH4, that is methane gas. And because they are non-polar molecule, they do not have a permanent electric dipole moment. If such a non-polar molecule, they are kept in what? External electric field, then what happens to the center of positive and negative charges? They get displaced, and as a result of which electric dipole moment can be induced in non-polar molecule. Electric dipole moment, it can be induced in non-polar molecule. And remember, for water, electric dipole moment for water, there might be a question in MSCT, what is the electric dipole moment for a water? Electric dipole moment for a water, it is 6.172 into 10 to the power minus 30 coulomb meter, or it may be 1.85 dBi. It may be what? 1.85 dBi. Now let us consider, or let us derive, what is the couple acting on electric dipole, which is kept in what? Uniform electric field. So look at this. Here we are having an electric dipole such that charge minus q is kept at point A and plus q is kept at point B, and they are separated by a distance 2L. Here the axis of dipole, it makes an angle theta with the uniform electric field. E represent the uniform electric field which is inclined at an angle theta with the axis of a dipole. We know very well that as far as charge minus q is concerned, this electric field will exert a force both on minus q charge as well as what? Plus q charge. As you know, electric intensity is nothing but force per unit charge, or force acting on an electric charge due to uniform electric field of intensity E is F equal to E into Q. So the force acting on charge minus q, which is at point A, force acting on minus q charge at point A, Fa must be equal to, See here, what is that charge is minus q into E. E is a vector. So negative sign here, it indicates that the direction of force acting on charge minus q and that of direction of electric field intensity, they are opposite. As E is pointing towards right, so that's why force on charge minus q due to electric field of intensity E, it is acting in a direction opposite to that of direction of what? Electric field intensity. Means E and Fa, they are oppositely directed because that charge is a negative charge. Similarly, we are having a charge plus q. That charge is also kept in uniform electric field. Means that charge is also acted upon by some force. And what is the force acting on charge plus q, which is kept at point B? Say it is denoted by F suffix B. And force is nothing but charge at point B, which is plus q, into the electric field of intensity E in which that charge is kept. Here positive sign indicates that the direction of force acting on charge plus q at point B is the same as that of direction of what? Electric field intensity. So that's why here FB, it is shown by means of an arrow pointing in a direction same as that of direction of what? Electric field intensity. So as far as electric dipole is concerned, the two equal and opposite charges, they are acted upon by force Fa and Fb. And from the figure, what you can say? As far as force Fa and Fb are concerned, the two forces, they are equal in magnitude. And what is that magnitude is Q into E. But they are, one is pointing towards right, other is pointing towards left. It means two forces are equal in magnitude, but they are acting what? Opposite in direction. Hence, they are forming a couple because their line of action of force do not coincide. Whenever we are having a pair of forces which are equal in magnitude but opposite in direction, and whose line of action of force, means if I draw a line over here, that will represent line of action of force. Here you can draw a line that will give you what? Line of action of force. These line of action of forces, they are separated, they do not coincide. So whenever we are having such pair of forces which are equal in magnitude but opposite in direction and whose line of action of force do not coincide with each other, then they are going to form a couple. And remember, moment of a couple is called moment of a couple. It is called as a torque. Moment of a couple, or you can call it as what? The torque. So the torque acting on an electric dipole or a couple acting on this electric dipole due to the uniform electric field, it can be obtained like this. Say, draw a perpendicular and extend this force, so they will meet at point P. If this angle between direction of electric field and the axis of dipole is theta, this axis, this angle is also theta. This angle is also what? Theta. Remember, as far as torque is concerned or moment of couple is concerned, torque is defined as the product of perpendicular distance between the two forces, say it is vector D, and the force and one of the force. So torque is a vector and that is equal to perpendicular distance between the two forces. What is that perpendicular distance here? This point is B, this point is A. Perpendicular distance between the two forces means it is arrow BP. And force is vector F. Remember here, the force F is equal to Q into vector E. So the torque acting on an electric dipole due to uniform electric field, it is equal to that arrow BP into what? Force F. F means it is Q into E bar. Therefore, magnitude of torque, if I just consider only the magnitude part of a torque, so magnitude of torque is equal to magnitude of one of the force into perpendicular distance between the two forces, that perpendicular distance between the two forces BP. It is also known as moment arm. It is also known as what? Moment arm, because it is responsible for rotation. So magnitude of force is Q into E, and moment arm here it is equal to BP. Now look at this. In right angle triangle APB, it is a right angle triangle. So in right angle triangle, APB, what is sine theta? Sine of theta is equal to opposite side BP divided by hypotenuse. So opposite side divided by hypotenuse is AB, and we know that AB equal to 2L. Therefore BP is equal to 2L into sine of theta, means perpendicular distance between the two forces which are equal in magnitude but opposite in direction is what? 2L sine of theta. So the magnitude of torque acting on an electric dipole due to uniform electric field is QE into that perpendicular distance is what? 2L sine of theta. But you know very well that electric dipole moment, it is defined as product of magnitude of either of the charge multiplied by perpendicular distance between them. So by using this P equal to Q into 2L, here you can have Q into 2L, and you can replace that Q into 2L by P. So this is PE into sine of theta. Magnitude of torque is PE into sine of theta. You can have the relationship in terms of vector also. So vector torque, that is torque acting on an electric dipole, it can be written as vector P cross of vector E, because P cross E is nothing but PE sine of theta. P cross E is nothing but what? PE sine of theta. Now as T equal to PE sine of theta, we will have two separate cases. Case number one, if angle between the axis of dipole and the direction of electric field. See here, this is axis of dipole, means here we are having minus Q plus Q charge, and here we will have axis of dipole, and here it is the direction of electric field. If angle between axis of dipole and the direction of electric field is 90 degree, what is sine theta equal to? Sine 90 equal to? You know very well from the sine curve, sine 90 is equal to plus 1. So sine 90 is plus 1. Therefore, the torque acting on electric dipole, which is PE sine of 90 is equal to PE, means you can say the torque acting on an electric dipole is a maximum, and that maximum value equal to PE only when the angle between direction of electric field and that of axis of dipole is 90 degree. So remember, whenever electric dipole is kept perpendicular to the direction of uniform electric field, then that electric dipole is acted upon by a maximum torque, and the magnitude of that maximum torque is what? P into E. P into E. Similarly, there is a second possibility, that electric dipole moment minus Q plus Q and that of direction of electric field both are coinciding. Means electric dipole is kept parallel to the direction of electric field. So the angle between direction of E and the axis of dipole, theta equal to 0 and sine 0 equal to what? 0. Therefore, for this situation, torque acting on electric dipole, which is kept parallel to the direction of electric field, it is T equal to PE sine of 0. Sine 0 is 0, means the torque acting on electric dipole is minimum or 0 whenever that electric dipole is kept parallel to the direction of electric field. So you remember, whenever electric dipole is kept parallel to the direction of electric field, then torque or couple acting on electric dipole is 0 or minimum, whereas whenever electric dipole is kept perpendicular to the direction of electric field, then the torque acting on electric dipole is maximum, and that maximum torque is equal to what? P into E. So this is all about what is the couple acting on an electric dipole whenever that electric dipole is kept in what? Uniform electric. So let us just derive an expression for electric intensity at a point due to an electric dipole. That point may be a point on axis, that point may be a point on what? Equator of a dipole. So the first case we will consider that point is an axial point. So here we are having an electric dipole formed by the two equal and opposite charges minus q and plus q, which are kept at point A and B, separated by a distance 12, and C represent the center of an electric dipole. Now as far as this line is concerned, line joining the given two charges, it is known as what? Axial line of dipole, and P is any point on the axis of dipole such that point P, it is at a distance r from the center C of a dipole, and we are interested in finding what is the electric field intensity at point P due to electric dipole. What we want to find out? Electric field intensity at any point P along the axis of a dipole. Along the axis of a dipole. Remember here, electric field intensity, resultant electric field intensity at an axial point P, say it is denoted by EA, then it must be vector sum of what? Electric field intensity at point P due to charge minus q at point A is EA, plus electric field intensity at point P due to charge plus q at point B. It is vector sum of electric field intensity at point P due to negative charge as well as what? Due to positive charge. And remember that electric intensity at any point due to a charge is directly proportional to that charge, and it is inversely proportional to what? Square of distance of that point from that charge. So naturally, electric intensity at point P, due to charge minus q at point A, it is equal to 1 upon 4 pi epsilon 0, this is constant of proportionality, into charge at point A is minus q upon square of distance between charge and point P. See here, point P is at a distance of r plus L. See here, P to C, distance is r, C to A, distance is L. So r plus L is the total distance of separation between point P and charge minus q. So this is r plus L whole square. And because electric intensity is a vector, here we must write some unit vector, and that unit vector is PD cap. Remember that electric intensity at any point due to negative charge, it is always that electric intensity is directed towards negative charge. So that's why this EA, it will act towards the direction of what? Minus q, means EA acts along the arrow PD. In which direction this EA will act? It acts along P to D. Therefore, this PD cap, it will represent a unit vector. PD cap is a unit vector along PD. Here PD cap, it is a unit vector acting along what? PD, and directed towards what? A negative charge. Similarly, here PD represent a unit vector. Now, electric intensity at point P due to charge plus Q, because this plus Q charge will also contribute in the resultant electric intensity at point P. So, the electric intensity at point P due to charge plus Q at point B, it must be equal to 1 upon 4 pi epsilon 0. What is the charge at point B? It is plus Q. And what is the distance of that charge plus Q from the point P? See here, I want to calculate distance BP. So, it is R minus of L. BP equal to PC minus of CB, that is R minus of L will gives you the distance. So, R minus L whole square into. Now, the electric intensity at point P due to positive charge. So, how is the direction of that electric field intensity? Electric field intensity at point P due to charge plus Q at point B, it must be directed away from that positive charge. So, that is why this EB at point P is shown away. Means this EB will act along what? Along the direction of arrow PQ. So, PQ cap, PQ cap, it is a unit vector. PQ cap, it is a unit vector, acts along the axis of the dipole and directed from what? Point P towards point Q. Point P towards point Q. Now, the resultant electric intensity at an axial point. If I say the resultant electric intensity at point P, which is an axial point, then it must be equal to vector sum of electric intensity at point P due to negative charge and electric intensity at point P due to what? A positive charge. Now, if you just observe equation 1 and that of equation 2. In equation 2, see here denominator is R minus L whole square. Here denominator is what? R plus L whole square. Denominator is less. It means this EB is more than that of, greater than that of what? EA. Naturally, rest of the terms are same. So, EB, mod of EB is always greater than mod of EA. Mod of EB is greater than that of what? Mod of EA. So, therefore, the magnitude of resultant intensity, magnitude of resultant intensity of electric field at an axial point, it is equal to sum of magnitude of EA and that of what? EB. What is EA equal to? It is equal to EA. Look at this. It is what? Q divided by minus Q divided by 4 pi epsilon 0 into 1 upon what? R plus L whole square plus EB. EB is what? Plus Q divided by 4 pi epsilon 0 into 1 upon R minus L whole square. R minus L whole square. So, what you can take common? You can take Q divided by 4 pi epsilon 0 as common. So, in bracket we are having, see here this is a negative term whereas this is positive term. So, it is R minus L whole square minus 1 upon R plus L whole square. Or this is equal to Q divided by 4 pi epsilon 0. Now, as far as denominator is concerned, R minus L whole square and R plus L whole square, their product, if you take their product, it will be R square minus L square whole square, and in the numerator R plus L whole square, R plus L whole square minus of R minus L whole square. Or this is equal to Q divided by 4 pi epsilon 0 in bracket. Now expand that square. So this is R square plus 2RL plus L square minus. Now expand this R minus L whole square. So it is minus R square minus L square plus 2RL. and whole divided by r square minus of L square whole square. So see here, plus r square minus r square plus L square minus L square, they get cancelled. And what is left in the numerator? In the numerator, the term which is left here, E axial, magnitude of electric field intensity at any point along the axis is found to be equal to Q divided by 4 pi epsilon 0 in bracket 2RL and 2RL, means it is 4RL divided by R square minus L square whole square. But remember, electric dipole moment P is equal to Q into 2L. P is equal to what? Q into 2L, or it is 2QL. So as far as the numerator is concerned, E axial is equal to, see here, Q4RL. That 4RL can be written as what? 2 into 2RL. So Q into 2 into 2RL divided by 4 pi epsilon 0 R square minus L square whole square. So here Q into 2L, see here, Q into 2L. You can replace that Q into 2L by what? By the electric dipole moment. So E axial is equal to magnitude of electric field intensity at any point along the axis due to electric dipole. It becomes equal to 1 upon 4 pi epsilon 0. Here this Q into 2L, it becomes P, and here it is 2PR divided by R square minus of what? L square whole square. R square minus of L square whole square. Remember here, because the magnitude of EB is greater than magnitude of EA, the direction of resultant electric intensity is what? It is along the direction of EB, that is directed away. Means the resultant electric field at any point along the axis, E axis, its direction is the same as that of direction of dipole moment, because electric dipole moment is pointing from what? Negative charge towards the positive charge, and electric field, resultant axial electric field, it is also acting along the direction of what? An electric dipole moment, along the direction of electric dipole moment. Remember here, in case when R is very large as compared to that of L, when R is very large compared to that of L, means L square can be neglected as compared to that of what? R square. Therefore, we will have the resultant electric intensity as R is very greater than L square can be neglected as compared to that of R square. Therefore, electric field, resultant electric field at any point along the axis of an electric dipole, it is equal to 1 upon 4 pi epsilon 0 2PR divided by, see here, R square minus L square, it becomes equal to what? R square. Because L square is very small, and R square is whole square, means it is R raised to 4. So R raised to 4 and R here, so one R get cancelled. So finally you can say that the electric field at an axial point is 1 upon 4 pi epsilon 0 2p divided by R cube, 2p divided by R cube. So this is about the magnitude of resultant electric field intensity at any point along the axis due to an electric dipole, and this direction of resultant electric intensity, it is away, it is along the direction of an electric dipole moment. So you remember that there might be a problems that find the electric field intensity at any point along the axis due to what? Due to an electric dipole. So electric field intensity or electric intensity due to an electric dipole along the axis, it is 1 upon 4 pi epsilon 0 2p divided by r cube. You remember 2p divided by r cube. Now we will find out what is the electric field intensity due to electric dipole along the equatorial point. Now let us derive an expression for electric field intensity due to an electric dipole at any point along the equator of a dipole. So look at this. Here we are having an electric dipole formed by a charge minus q at point A and plus q at point B, and they are at a distance L from the center C of the dipole. And here C represent, here look at this vertical line. It is a line which is perpendicular to axis of dipole and passing through its center. So this CP will represent equator of an electric dipole, such that P is any point at a distance r from the center C of an electric dipole. And here we are interested in finding what is the electric field intensity at point P due to an electric dipole. So you know very well that as P is a point on an equator, so electric intensity at point P due to charge minus q at point A, it is given by expression EA cap or vector EA equal to that constant of proportionality 1 upon 4 pi epsilon 0. Charge at point A, it is a minus q upon distance between point P and A, it is AP square into, here be careful because we are calculating the electric intensity at point P due to negative charge. It means that electric intensity EA, it must be pointing towards point A, so it must be multiplied by a unit vector PA cap. What is PA cap? PA cap, it is a unit vector. PA cap, it is a unit vector and pointing towards point A, from point P towards point A. Similarly, that another positive charge at point B will also contribute to the electric field intensity at point P. So the electric field intensity at point P due to charge plus Q at point B, it is E suffix B, and it is equal to constant of proportionality 1 upon 4 pi epsilon 0. What is the charge at point B? It is plus Q. So it is plus Q divided by, now the distance of point P from point B, it is BP square into, remember electric intensity at any point due to positive charge is always directed away. So intensity at point P due to positive charge, it will act along the arrow what? PQ. So it is multiplied by a unit vector PQ. So PQ is a unit vector. PQ cap is a unit vector. And how is its direction? That PQ cap, it will act along the direction of vector PQ, arrow PQ. PQ cap, it is a unit vector, it acts along the direction of what? PQ cap. So, as far as equatorial point P is concerned, both negative as well as positive charge, they will contribute in the electric field intensity at point P. And remember, the resultant electric intensity at an equatorial point P, it is actually the vector sum of intensity of electric field at point P due to charge minus Q and due to charge plus Q. Means here you can write that vector sum as E equatorial is equal to vector EA plus vector EB. Vector EA plus of vector EB. Now, as far as triangle, any right angle triangle, you may consider either as PCB or you may consider right angle triangle PCA. See here, in a right angle triangle PCB, what is hypotenuse square? Hypotenuse square means PB square or BP square is equal to What is BP square? Hypotenuse square is equal to CB square plus PC square. What is PC square? R square. CB is what? L square. Means here the length of hypotenuse is equal to under root of R square plus L square. And same is the situation for right angle triangle what? ACP. Here you will get AP is equal to under root of R square plus of L square. So you can put the value of AP or BP in the expression for electric field intensity EA or EB. So you will get magnitude of E equatorial or magnitude of EA, its mod is equal to 1 upon 4 pi epsilon 0 minus Q. Magnitude, when you are taking the magnitude, whether it is charge minus Q or plus Q, it becomes Q only, upon AP square. What is AP? Equal to under root of R square plus L square. AP square means R square plus L square, R square plus what? L square, and magnitude of unit vector is 1. Similarly, magnitude of that another electric field intensity EB is equal to 1 upon 4 pi epsilon 0 Q divided by, again here this distance BP is equal to R square plus L square, and its square is there, so it is simply R square plus L square, because BP square equal to R square plus L square. So if you just compare equation 1 and equation 2, look at this, 1 upon 4 pi epsilon 0, 1 upon 4 pi epsilon 0 Q divided by R square plus L square divided by R square plus L square. So what you conclude? That the magnitude of electric intensity at point P due to charge minus Q and due to charge plus Q, that is EA and EB, they are equal in magnitude. EA and EB, they are what? Equal in magnitude. But EA is acting along the direction of PA, while EB is acting along the direction of what? PQ. And we want to find out the resultant electric intensity at point P, that is E equatorial. So we can make use of the method of resolving the vector into two rectangular components. Look at this. Here at point P, we know that EA will act along this direction, that is towards the negative charge. EB will act along what? Along this direction, that is away from the positive charge. So you can resolve this EB as well as EA into two rectangular components. See here, as far as this arrow is concerned, EB makes an angle theta with this component, and you know very well that whenever vector is resolved into two components, that component which makes an angle theta with given vector, it must be what? A cos theta. So EB, one of the component of EB which is along the diagonal of a parallelogram, as it makes an angle theta, therefore this component of EB along this direction is what? EB cos theta. See here, this direction is parallel to the axis of a dipole. It means you have to resolve electric field intensity into two rectangular components. One of the component must be along the equator, while other component it must be what? Parallel to the axis of a dipole. So the component of EB parallel to the axis of dipole is EB cos theta, while perpendicular, or while that component of EB which is along the equator, it must be what? EB sin theta. Similarly, you are having another vector EA which makes an angle theta. It means the component of EA along this direction, it is EA cos theta. Means component of EA parallel to the axis of dipole is EA cos theta, while the component of EA which is along the equator, it is what? EA sin theta. And remember that EA and EB, because their magnitudes are same, therefore EB sin theta and EA sin theta, they are equal in magnitude, but they are acting what? Opposite in direction. Hence they will cancel the effect of each other. So the resultant magnetic field, resultant electric field at point P, at any equatorial point P, due to an electric dipole, It is actually the sum of E equatorial magnitude of resultant electric field intensity at any point P along the equator. It equal to what? It is the sum of EA cos of theta plus EB cos of theta. But we know that magnitude of EA equal to magnitude of EB, means E equatorial is equal to EA cos of theta, plus you can replace EB again by EA. So this is EA cos of theta. So this becomes 2 times EA cos of theta, or it is equal to 2 into. Now look at this magnitude of EA. It is 1 upon 4 pi epsilon 0 Q divided by R square plus L square, R square plus L square. Now into cos theta. How to find out cos theta? See here, in triangle BCP, in triangle BCP, cos of theta is equal to adjacent side CB divided by hypotenuse, that is BP. CB is equal to L, so L divided by that hypotenuse is under root of R square plus L square. So you can put the value of cos theta equal to L divided by under root of R square plus L square. So this becomes L divided by under root of R square plus of L square. So electric field intensity at any point P along the equator due to electric dipole, it can be written as, see here, 2Q into L. What is this 2Q into L? It is equal to electric dipole moment P. So E equatorial is equal to 1 upon 4 pi epsilon 0 P divided by 1 upon 4 pi epsilon 0 P divided by, see here, R square plus L square into R square plus L square square root, means it is R square plus L square raised to what? 3 by 2, raised to 3 by 2. And remember that if this R is very greater than that of L, then L square can be neglected as compared to that of R square. L square, it can be neglected as compared to that of what? R square. And under that condition, E equator is equal to 1 upon 4 pi epsilon 0 P divided by, see here, R square plus L square, it is simply R square raised to power 3 by 2, R square raised to power 3 by 2, this 2 get cancelled with 2, it means it is R cube. So it is 1 upon 4 pi epsilon 0 P divided by R cube. So this is an expression for electric field intensity or intensity of electric field at any point along the equator due to an electric dipole. And remember that E axis and E equator, what is that formula for E axis? E axis is equal to 1 upon 4 pi epsilon 0, and we are having 2P divided by R cube. So E equator is 1 upon 4 pi epsilon 0 P by R cube. E axis is equal to 1 upon 4 pi epsilon 0 2P by R cube. Means what we can say, that electric field at any point along the axis is 2 times electric field at any point along the equator due to an electric dipole. So this is all about electric intensity at a point due to an electric dipole.